Today we're beginning Chapter 10, dealing with counting methods, and we're taking a look at Section 10.1 on counting by systematic listing. In this particular section, we look at a variety of ways to count by systematic listing, and what we do is we begin with the simplest task and work up to the more complicated ones. So we begin with one part task, and this is the simplest of the listing, systematic listing counting problems. And so, for example, consider a problem where a paper bag contains 6 marbles, one each of the colors red, yellow, blue, green, orange, and purple. How many color possibilities are there when one marble is drawn from the bag at random? Well, easily we can see there are 6 colors, and so there are 6 possibilities in this case. So one-part tasks are fairly simple. Now let's move on to the two-part task. Two-part task can for those we can create what is called a product table. And so we're going to consider rolling 2 fair dice. One is red, and let me use my highlighter here. The reds are in the column, and the other die is green. So across here we have green. So in our ordered pair we have the red and then the green. The red is on the left and then the green is in the second position. So in the first case our roll would be 2 ones. To the right of that we have a 1 on the red and a 2 on the green. A 1 on the red, a 3 on the green. So that's the way our table works. And if you count the number of possible rolls, we can see we have 6 in each of 6 rows. So 6 times 6, we have 36 possible results when we're working with a two-part task. Okay, so here's an example for you to try. Consider a two-part task where a club of 6 people is electing a president and a secretary from the membership. Assume that no one can serve in 2 offices. The members are Alice, Bob, Candy, Dan, Eddie, and Fran. In how many ways can the club elect a president and a secretary? So what I want you to do is take the time to draw a table and figure out all the different possibilities. You can leave it in a table just like we did with the 2 dice. So what you're going to have is perhaps the column will be the president, and across the top you'll be doing the secretary. And you can just use the first letters of the names, because notice Alice, Bob, we have A through F alphabetically. So you can use A to represent Alice, B to represent Bob, C to represent Candy, D Dan, E Eddie, and F Fran. So go ahead and see what you come up with, how many possibilities you have for this particular case. And like I said, you can just leave it in the table format. So pause the recording now and draw the table, and then when you're ready to check your work, go ahead and restart the recording. Okay, I'm assuming at this point in time that you have actually done the table. So we have a 2-part task. So get my table started here. We'll do president down this way, and you would have A, B, C, and I may not go through the whole thing, D, and looks like I'm going to be tight on space here, E, and then there would be an F. Okay, so I would need one more row there. Okay, and then across the top you want to do the secretary. So, and again, I'm going to have the same possibilities. This time I have too much space. Okay, but notice we have to eliminate A can't be both president and secretary. Same with BB, same with CC, DD, EE, and FF. I need to make these go all the way down to my F. So those would be X'd out. So you could have AB, AC, AD, AE, AF, BA, BC, BD, BE, BF, and so forth. So basically we have a situation very similar to what we have with the dice, except with the dice we could duplicate the same number on both dice. So it turns out again we have 1, 2, 3, 4, 5, 6 across, but this time we can only have 5 in each row because we're losing 1, times how many different rows? We have 6. So it turns out there are 30 ways to elect a president and a secretary. So it's we lose 6 cases like we would have with the dice because we can't duplicate A, and A can't be president and secretary, and the same with B and B, C and C, and so forth. So you would continue the table the way I have started it here. Alright, now we also have parts that have more, tests that have more than 2 parts. And those get a little bit more complicated. Each time we increase the number of possible parts, it does become much more difficult. So suppose we're doing tossing 4 coins, a penny, a nickel, a dime, and a quarter. How many possible outcomes are there? Well, the way we can do this is by doing what we call a tree. And we begin with the penny toss, and there are 2 possibilities when we toss the penny. We can get heads or tails. Then when we toss the nickel, if the penny is heads on the nickel, we can have heads or tails. If the penny is tails on the nickel, we can have heads or tail. Okay, now if the penny and nickel are both heads, then we can have heads or tails on the dime. If we have heads and then tails, the dime could be again heads or tails. And so we complete the possibility for the dimes. Alright, now if we have heads on all 3 coins, the quarter, again can be heads or tails. And if we have heads, heads, tails, we can then go to heads or tails. Heads, tails, heads, we can go to heads or tails. Okay, and I'm just going to fill this in instead of continuing to repeat myself. Now the way we read these, and I'm going to use the highlighter to go across the very first one here, we can do heads, 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 heads. So you can see what I have there. Let me see if I can get a different color. Let's see if I can do a green. Alright, for the second one we have heads, 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 tails. And let's get a light blue. We can have heads. Nope, I still have green. Let me get the blue. Okay. We can have heads, heads, tails, heads. Okay, and then heads, heads, tails, tails. So I'll put 2 blue ones in there. And we would continue that process down the tree. Heads, tails, heads, 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 tails, heads, tails. So that's those 2. Heads, tails, tails, heads. Heads, tails, tails, heads. Tails. Okay, so you continue down, going out the branches that way to come up with all your possibilities. And what we see is there are 16 possibilities in all. Now, of course, it is rather lengthy to have to write all of these out, but in some cases that is the best we can do. Okay, I'm going to stop this recording and we'll continue the lecture in a second recording, and we'll talk about some an additional example, and also an additional method for counting where we have many more than two parts.